Okay.
So in the previous classes, we have already talked about the architecture basics, how this is going to work, what will the flow of the query. So in this session, we will explain the part. So let me go with this. This is the client side, and this is our server side. So how if user fire a query, so user will fire a query, and the protocol layer with text with the help of SNI. SNI is there on the both the side in the form of TDS. TDS is nothing but it's a
Yes,
tabular data
yes.
stream, and in the protocol layer, here the query will be unencrypted. We will got the actual query. So let me go with the protocol layer. So how communication is going to be made? So we will talk about this first communication protocol in the protocol layer, that how this is going to communicate. So basically we have three communication protocol in the SQL Server. So first one is the TCP/IP, second one is the names pipes, and third one is the shared memory. So what does this mean? So shared TCP/IP means that our machine, TCP/IP means that our machine is in this India location, means client, and this is the server, this is the client. So client, and this might be in the India, and this might be in the US, right? So TCP/IP means that the client and server both exist on the two different locations, and with the help of TCP/IP we are going to make a remote connections if the client and server are on the two different locations, right? Just like the India and the US. In that scenario we are going to use the TCP/IP. So what is the named pipe means? So what is the, suppose there is one company, suppose there is one company TCS, and two building is there. This is the building 1 and this is the building 2. This is building A and this is building B. So suppose if my the client server machine is on this building, suppose it is there in somewhere in this building A, and client is on the second building. But what is the difference here? That the distance is less. We are in the same campus, TCS campus, two building is there. One is A, is just like the uh, local LAN connection, just like the LAN, local area networking, just like. So in that scenario, we are going to use the named pipes. And shared memory, what does shared memory means? That the client and the server both exist on the same machine, right? So client and
Right.
server,
Named is just like for a college or a university campus or something like that, na?
yes,
Intranet.
yes, right. So connection will be made with the help of the named pipes. But if the shared memory, what does shared memory mean? Shared memory means that the client and server both exist on the same machine. So let me go back to the uh,
Client and server is on the same machine.
just a minute. So where we will check the communication protocol, we will go to the configuration manager. See, here we have the shared memory is there, named pipes is there, TCP/IP is there. So if this is on the two different locations, then separated by distance, we are going to use the TCP/IP. Shared memory means that both this exist on the same machine, and named pipes means that they are in the two buildings, just like one campus is there, and these exist in the two building. Then in that scenario, we are going to use the named pipes. So this was about the how we are going to make the connections in the SQL Server. So authentication handling.
Technically, Abhishek, what is the, like you are saying by example that two buildings are there. So, but what is the technical definition? What how we can how we can describe it, the pipes and
The named pipes
Intranet.
means, yes, right.
Intranet.
It's just like the local area networking. How we are connecting? We are using the
it's
LAN
a local
connection,
area
na?
networking. Okay.
Uh,
Hmm.
just give me 1 minute. Someone is there. Just a minute. Earlier, what was there in the Wi-Fi? We were using the LAN connections. So it was connected with the help of cables. So just like the same, this is the named pipes is the communication protocol.
Okay.
Am I audible? Yes. Now after the authentication,
Yeah, yeah.
handling is also there. So protocol layer also manage the authentications. That what does authentication means here? The secure access to the server. They are going to authenticate the credentials in the
The
protocol
user and
layer.
password. Yes,
Yes,
yes.
right. Credential in the protocol layer. Error handling is also then the part of the protocol layer. So if there is any error occurred during the communication, then the protocol layer is going to throw the error message and send back to the client. Right. So the one more thing was there that when so this was the communication protocol, that how the communication is going to make between the server and client, right?
And
That
is
how
also going to in protocol layer.
what
Encryption and
SQL Server, SQL Server.
SQL
so
Server. Okay.
encryption is something different. We will talk about this part. So this is the client and this is the server. This is the server and this is the client. So how communication, the help of the protocol layers, this communication is going to be made. So there is one more thing which is known as TDS. So what does TDS here means? TDS is the full form is the tabular data stream. So when TDS means it's just in the form of packet, that TDS is we can say it is a packet and it is transmitted in the form of that packet, which we are calling this as a TDS. Earlier TDS was a part of Sybase, but later it was taken by Microsoft. Fine.
Sorry, can you come again, Abhishek? What you said about TDS that is
TDS
managed
is
by
nothing. It was earlier it was designed by the Sybase, but later it was taken by the Microsoft. Now the TDS is
okay,
a part of the Microsoft.
okay,
So
yeah.
this they already covered that how this is going to be query processing. We already covered. So now after that we have the relational engine is there.
The role of protocol layer and query processing.
Yes, we already learned about this in in the first part. Now that query is going to be unencrypted in the protocol layer. Here we will get the
Yeah,
actual
yeah.
query.
Okay, okay. Yeah, correct, correct, correct.
Yes. Now after that this part we are moving to the relational engine. See, we already covered near about the 70% part in the first class. Only 30% the part which required just like the communication. I haven't um, uh, we haven't go with the communication protocol, so that the things will be easy to understand in the first classes. So the relational engine. So We can say the relational engine is basically for the query processing. So we can say this is the heart of the query processing. Everything's the how query is going to be processed. This is going to be defined in the relational engine. So first part we have in the CMD parser. So what is happening once the data is received from the protocol layer, then after that it is moved to the which layer? Relational engine, and relational engine it went to the CMD parser, right? So what is the prime responsibility of the CMD parser? Can anyone?
To
What
check
CMD
the
part?
semantic and
Yes.
syntactic
So yes,
errors.
right, right. So this is going to check the syntactic and semantic error. This is going to be checked in the CMD parser. After if everything is fine, then what CMD parser do? It's create one
Mm.
query tree. A query tree is nothing. It's just a structured representation of the query. So once we already learned, I think we already learned about this part that in the first class, syntactic semantic we already covered. So
Yeah, yeah, yeah.
yes, yes. Just a minute. So this is the this is the difference between the syntactic and semantic error. You can go with this diagram and to see that what difference is there. But remember simple things about what semantic and syntactic error is going to do. After that, there is query trees. Query tree is generated. So this is nothing just like the what is happening here. The multiple execution trees are generated. So here the plan they see it represent a different way that the query can be executed, but the result will remain here the same. Now that query optimizer. So yes, we have talked about this part that what query optimizer do. This identify the most efficient way in which the query can be executed. Cost-based optimization is there, that how much it is going to use the CPU, uh, IO operations, memory requirement. Everything is going to be done in the query optimizer. For example, example is there that use index to fetch. We already covered about the index, right, in the first part. We have gone with the basics overview of the index, right? That what is index. I'm
Yeah,
audible?
yeah.
Yes, yes. So for example, there
Yes.
is one table, and so what we can do if we want to face the rows department is equal to finance. Department is what here? Department is one column,
Column type.
and uh, we want to face the data for the department is equal to finance. So what there are two ways to face. What is the one way that it will do the full table scan, just like we are going with the books
Mm.
page one by one. So this is going to take time. This is going to take more CPU, everything. And another is to with the help of the index that it will point to that
I do that.
index, and it
Yes.
will be easy for the processing also. We already covered this part also in the part which was we haven't covered, that what are the steps performed by the optimizer, how this is going to handle the queries. So in optimizer we have three phases there. Phase 0 is there, phase 1 is there, and phase 2 is there. So suppose if we have very simple queries there, so uh, the query which is very simple that does not require any optimization, so this will go into the phase 0, right? Phase 1 is just what does it focused is focused on the fast and efficient plan just for the transaction. Suppose we have the banking project is there, so what does it require? It required the fast processing, so it will go for the phase 1. And what does the phase 2? That suppose we have one some uh, big queries there which require exhaustive optimization is there. So in that scenario, it will go with the phase 2. So let me talk about the phase 0 first. For example, suppose I'm running one query, select a star from the employee, where employee ID is equal to 101. So does it require any optimization? It is very simple query, right? And here the employee ID is the primary key. So this is directly going to use the index, and it is going to fetch the data. So it does not require any further optimizations. So this type of query will be there in the phase 0, right? This is for the
Yeah.
basic query, just like the basic query. This will be there in the phase 0. So now we have phase 1 is there. So basically, this is for the OLTP transactions. OLTP stands for the online transaction processing workloads. So for example, there is one query running, right? One query is running. So there are two possible way, right? So what is the two possible way? One way is that, so what is there in the phase one? The phase one means that it will go with the fast. uh, our main aim is to uh,
Shortest path first, huh? Like
what?
that. Shortest path first.
No, it is going to see, this is not going to check the best plan. So but this is going to check for the, if it,
Fastest plan.
yes, right. So there might be, see, there is one, there might be, see, if my SQL Server is working on this query, so there is a possibility that it might takes time to find the, best possible plan, right? Suppose it takes the 25 seconds to find the best possible plan, right?
Okay.
But suppose this query is running, so before going with the search of the uh, plan, that it can go with any of the plan, and if it is going with any of the plan, it takes only 15 seconds. So why to do search for these transactions? So there is one plan
Hmm.
is already there, so this plan is taking only 15 seconds.
15
but
seconds.
but this plan we have, this, if it is going to search for the best plan, so searching the best plan will take time. Suppose it takes the
Hmm.
25 seconds to search the plan, and it selected one plan, then after execution will take 5 seconds, right?
Hmm.
It search for the best plan, after that execution takes the 5 seconds, the total is 30 seconds.
30 seconds.
But here it is going with the one plan. This is not the best plan, but this is taking only 15 seconds, right? So what it
Hmm.
will do? It will go with the second plan. So this is going to be do in the phase one, right? Basically, just like for the banking operations, is there OLTP transaction is there, and that for this, this is going to be phase one. So what is it? Its feature that it is going to prioritize the execution speed. This is not going to do the exhaustive analysis of the all possible plan, right?
Hmm.
So this is going to balance the cost and complexity for the transactional efficiency. For example, suppose we have a update employee set salary is equal to salary plus 1000, where department is equal to HR, right? So what is this table? This query involve only single table, right? And only simple condition is there. So in that scenario, optimizer is not going to focus on the what here will do, it will focus on the quick plan, right? It will not go
Hmm.
with the exhaustive analysis. It will focus on the quick plan, and after that it will show the result. So this will be the phase one. Now final is the phase two is there in the optimizer. So what is happening? Suppose OLAP is there. So this is the earlier was suitable for OLTP. So your task is that, today task is that, find out the difference between OLTP
Hmm.
and OLAP.
Lab.
Yes, this is your task for the next classes. Uh, Search on this topic, that what is OLTP and what is OLAP, and when we are going to use it. Fine. So yeah, just came to the topic that, suppose we are running one query, right? Let me go with the query first. See, this is our query, select department, and then we are going the average of the salary from employee. Then we are going group by the department, then having average salary greater than 50,000. So what this query involve, say grouping is also there, aggregation is also there, filtering is also there. So it required a deep analysis so that it can fetch out the best execution plan, right? So it will go with the parallel to optimization. Fine. So remember one thing, that phase zero is for the basic query, phase zero is for the simple query, right? Phase two is the, phase one is for the, we can say the OLTP, where it will not focus on the execution plan, it will focus on the, that quick which plan is going to give the quick result. This is going to be focused on the phase one, and phase two is for the complex query, right? So these all are the optimization which is going to be happen, where this is going to be happen in the optimizer, right? So all the things optimize this, all the things is going to be done by the optimizer, that how it is going to select the execution plan. So depending upon the phase 0, phase 1 and phase 2, this is going to select the this is going to select the plan. If it is the simple query, then it is directly going to run that query. If it is some OLTP transaction query is there, then it is going to focus more on the execution speed rather than on the exhaustive analysis. But it is a complex query is there, then it is going to focus on the it will search for the best plan, execution plan, and after that it will process, right? So this was about the deep analysis of the optimizer, right? So query executor, basically, what does query executor do? Any idea? See,
After the query optimizer, it once the plan is there,
it
once the
execute,
plan
yes,
is ready, then it executes.
yes. As per the chosen execution plan, what is there? Executor execute the query according to the chosen execution plan. This is the basics we have already discussed in the first class also, that how this is going to be flow, that how parsing going to be done. Everything's we have workflow of the lesson angel we have already covered in the part first, right? So let's go with the storage engine. So I think we have already covered most of the part of the storage engine, but let's have a again look on the storage engine part, the core components. That access method is there. So what does access method do? Basically, this is going to identify the query, right? If it is first, it will go with the checks that whether it is select statement or non-select statement. So based on the statement, suppose if it is select statement, then it is going to pass the query to the buffer manager for the further processing. But if it's in non-select statement is the DDL DML is there, then it is going to forward it to the transaction manager. See here, transaction manager, right? If it is select query, then it will go to the buffer. If it is not non-select query, then it is going to the transaction manager, right?
Yeah.
So what after that we have the buffer manager is also there. So what does buffer manager do? Basically, this is going to handle the memory management is done by the buffer manager. That what does it do? It caches the frequently used data pages in the memory. So why this is going to be do for the faster execution, right? If it will be in the buffer, then the execution will be the faster. It is not going to fetch the data from the data files. So this is I think we have already covered about
This
this
is
part
like a
also.
cache.
Right,
This is
right.
like a
Memory
cache.
management, yes. We already covered this part, that what is buffer manager is there, how it is going to be a sort parsing we have already covered in the, so no need to do it again. Data part, hard parsing we have already covered. This I think we have covered this part also. Log manager, recovery manager, data files we have covered. Data files. Hello, am I audible? Yes, I think we have covered the
No,
data files.
no.
Data files we have covered. This part, this is covered. Yes, this part is covered. Data we have covered about the uh, how, what is the flow, or how data when we are when database creating, how many file will be created?
49.
Yes, yes,
50,
right. What?
49 NDF, I believe.
No,
49
no, no.
NDF
One,
and
one,
one
no,
MDF.
no. One MDF will be there and one LDF will be there. One data file will be there. We are calling as a primary data file, and one log file
Yeah,
will be there. We are calling this as a
local.
LDF file. Just a minute. Give me 1 minute. So this was about the complete architecture for the SQL Server. Just a minute. Yes, there is one more thing is that if you talk about the physical hierarchy, if we talk about the physical hierarchy, then what? So how physical hierarchy is going to be divided? So first of all, what we have server, right? After that we have databases. After that, what we have? File groups and log file is there. What inside the file group? What is inside the file group?
Data
We
files will be there.
yes, data file is there. Or we can also say the data file as a MDF. Master data file is there. Or NDF file, new data file or next
India
data file
files.
is also there in the file group. New NDF. We can say new or next data file. Next data. Right? After that, what we have? We have extent. After that extent, what we have?
Blocks.
Pages. What is pages? Pages is nothing. It is a fundamental unit of storage. Page is the fundamental unit of, we can say that, uh, fundamental unit of storage. And what is the size of each one page? Each page is 8 KB.
8 KB.
Yes, and page are grouped into the extent. 8 pages. When 8 pages, we can say that.
8 page will form one
Yes,
extent.
yes, right. So what
So
will the size?
it's same like blocks in Oracle, right?
I'm not sure about this part, but this is for the SQL Server. The size of the one extent will be the how much? 64 KB allocation will be there for the one extent, right? Why how? One size of one page
Hmm.
is 8, so extent is pages are grouped into the extent, and
8.
we
Eight
yes,
is
8 pages is
pages.
there, so 8 ja 64. Yeah. So this was about the architecture part of the SQL Server. Just a
And
minute.
log files will be created on another side. Okay.
Yes, right. Log file. We have the yes. 1 minute.
Any particular diagram for it? This is
This is the physical hierarchy I'm talking about.
yeah,
This was just the
for
physical
hierarchy.
hierarchy. Yes. Data file groups will have yes.
If any diagram there, it will be better
Hierarchy is
for
nothing.
us.
We don't have diagram. You can search if you want. There we just like the structure we are creating.
Okay,
Just
okay.
so file group we have
NDF,
data
LDF,
file is there, and for the log file we have LDF file, and after that
LDF
we have yes LDF file is there. No? Log file extension is the LDF, right?
for both.
What is the extension of log file? LDF, right?
Log file for this LDF.
And after that we have
Correct.
extent, and after that we have pages. This is just the
Sequences.
physical hierarchy of the SQL Server. So this complete the SQL Server architecture. So we are completed with the architecture. So let me stop the recording.